viewers, welcome to Science Spectrum with Don. You're welcome to the second part of the third lecture in Math 187, the fundamentals of mathematics. And of course, this will be the continuation from the previous lecture in trigonometry. So just a quick one. Trigonometry was coined from three Greek words: tri, which means three, gonia, an angle, the metron, which is a measure of. So you could think of trigonometry as a branch of mathematics, okay, that deals with a measure of, okay, a shape with three angles. And of course, in this case, triangles, okay, fits best to this description. All right, so we've looked at a few types of triangles, right? And for today's class now, I want to start off with the units, okay, for angles. So let's talk about the units for angles. So I said an angle is formed when two line segments, let me see, this is point O, this is a line segment OA, another line segment, okay, OB, when they meet at a common endpoint. This is, okay, how an angle is formed. And of course, this angle, okay, is theta. And of course, a measure of the arc, if I had fitted this in a circle like so, this is not drawn to scale. So let's say this is a circle. And you're free to imagine this line segment now, okay, to be the radius, since it's a straight line that starts off from the center of the circle and is touching a point on the circumference of the circle. So this is the radius, and this is A, OA, line segment OA, that's the radius, and another radius, OB, right? So this angle is theta, right? So a measure of this arc is, so a measure of this arc, okay, is the same as the angle at the center, which we call the central angle. So this could be in degree, right? And of course this could be in radian. So there are two units here. We have the rad, that's radian. I need to write it properly. So this could be in radian, right? And of course this could be in degree. Okay, degree, as you like it. So we stick in, okay, this for degree, and else we abbreviate rad for radian. All right, so let's proceed. Now let me talk about, we need to build this for a while. All right, so let me talk about the two units, okay, of angles, and let's see how we can convert and interconvert between those two units, right? So the first one is the British units. We call that the sexagesimal system, okay, of units for angle. Okay, it uses 60 minutes for 1 degree. Okay, so this is to base 60. And of course we have the French units, which we call the centesimal. So from the word centi, this is 100, and this is 60. All right, so let's look at, okay, a few things here. Now, we could measure angle in this sexagesimal system, okay, in degree. So if you take one right angle triangle, just take one right angle, that is 90 degrees. So in degree, that's exactly 90 degrees, right? So 1 degree now, in terms of minutes, is 60 minutes. So minute has a dash or a prime. So this is minutes, 1 prime is a minute. Then 1 minute, this is 1 prime, in second, clearly is 60 seconds. So second is 2 prime. So this is really where the sexagesimal comes in, okay, base 60. All right, now, of course, for the centesimal system, one right angle like we have here, one right angle, which in the sexagesimal is 90 degrees, one right angle in the centesimal system is exactly 100 grades, right? 100 grades. And the grade is given, okay, by this symbol, little g. So the French use this units for angles. So just one right angle triangle divided into 100 equal portions. That's the grade. The degree is one right angle triangle divided into 90 equal portions, okay? That's the degree. All right. Now, one grade, okay, one grade is exactly 100 minutes. It's exactly exactly 100 minutes. Exactly 100 minutes. So that's why it's called a centesimal. That's where it really comes in now. Then 1 minute, which is just, okay, a prime. We're sticking a prime here. This is G, but okay, a prime is exactly 100 seconds. So, and this is exactly 100 seconds. So these are the two notable systems, okay, for angle measure. Now, of course, I could also fit in a measure of an arc, which we call the radian, right? So clearly, let me now, okay, stick in a pair of equivalent statement now, right? So I know that that 360 degree, that is when you go around a circle like so, okay? From the center, this is the radian. Okay, this is the radius, this is from the center. So when you go around a circle, you've covered 360 degree, right? And of course, that defines the circumference of the circle, right? And of course, in radian, that is exactly 2 pi radian, 2 pi rad, right? So if I divide both sides by 2, right, it turns out to be that, okay, this boils down to be 180 degree is equals to pi rad. So 360 degrees is 2 pi rad, 180 degrees pi rad. So this is a pair of equivalent statements by which you could convert between degree to, okay, and okay, the measure of the arc now, which is in rad, okay? So let me now give a pair of equivalent statements between degree, rad, and grade. All right, now 90 degree, okay, let me use 360. 360 degree, or let me use 90. 90 degree is equivalent to 100 grade, okay? And of course, in rad, you could just convert this. If I take this pair now, I'm converting 90 degree to radian, and we need to wipe this off. So just a quick one. How do you convert and interconvert between these units? Now, this is my given units. Okay, you are free to call that G1, the given units, the value given in the question in degree. Then I have to get a pair of equivalent statement now, right? So my pair of equivalent statement has to be a unit that relates degree, which is my given, to rad, which is the desired unit, right? So I have another given unit, okay, which should be in degree now. Then I should have my desired units, okay, which in this case should be in rad. So this is really a pair, and of course, at the time, this is a pair of equivalent statements that relates the given unit to the desired units, the one you're looking for in the desired, right? So this is a pair of equivalent statements, or we just call this a conversion factor. And clearly, the given unit is 90 degree times, so a pair of equivalent statement now that relates the given unit to desired, which is degree to rad. You are free to pick this pair, 360 degree equal to 2 pi rad, or 180 is pi rad, or you divide this out by 2, you say 90 degrees pi over 2 rad. So this is, so I could stick in the 180 degree here now, and I have the pi rad, which represents my desired unit. Why? That at last I could cancel out the given unit like so. Then I'm left with the values now, right? Then I will multiply out and I'm left with my desired unit, right? So let's see, 0 cancel out the 0, 99 is a 1, 9 and 18 is a 2. So 1 times pi is just a pi, I have over 2, and this is rad. So clearly, 90 degree in rad is exactly pi over 2 over radian. And of course, you can convert and interconvert between any of these units, okay? Using this pair of equivalent statements. And of course, you could also convert, okay, from degree to minute, right? Minute to second, of course, and vice versa. All right. So this is a pair of equivalent statement between the sexagesimal system and the centesimal system. All right. We need to read this for a while I do a few, okay, examples. All right. So let's take, for instance, that, for example, let's say, okay, I care to know what I'm converting now. Convert, okay, 360 grade, or 360 grade to, so the first one is to degree, to degree, and of course the second is to radian. Okay, and after this, I'll talk, okay, about conversion between degree to minutes, okay, in sexagesimal and centesimal system. Alright, so 360 grade now, solution. This is the centesimal system. So 360 grade, I could just stick in the G, okay, for the grade there. Now, all I need to do is to take a pure equivalent statement that relates grade to degree, right? So grade happen to be the given units like we have here, right? And of course, degree is the desired unit. So when I take a pure equivalent statement, I will have a degree here, and I will have, okay, right? Sorry, I will have the grade, which is the given unit, and I will have the degree, which is desired, the one I'm looking for. So clearly, I could pick this pair, right? So I know that that 100 grade, which is the same as the given unit, and so that at the end of the day, the grade cancels out the grade, is equivalent to 90 degree, right? So clearly, the grade cancels out, just like you see, the given unit cancels out, okay? Of course, I could have flipped it, depending on which is my desired and which is my given. So the goal is, the given unit will have to delete out the right, and I'm left with my desired up. Alright, so I lose the 0, right? And I also lose the 0. So all I'm left with now is just 36 times 9. So this is the same as, say, the times between 36 times, okay, times 9, and whatever I have, okay, should be in degree. So clearly, this is just as good as, say, 360 minus 36. Okay, 0 cannot subtract 6, so I take a 1, this becomes a 5, I have a 10. 10 minus 6 is a 4, 5 minus 3, that's a 2, then I'm left with a 3. So this is exactly 324 degree. This is, okay, another way you could multiply by 9. Alright, so I could now say, therefore, 360 grade, therefore 360 grade is equivalent to 324 degree. That's it, okay? So you do a normal way, you could say 36 times 9, okay? 36 times 9 this way. So 9 times 6 is 54. So if you write a 4, you carry the 5 over. 9 times 3 is 27. And when you add 5 to 27, right? Just add the 3 in 5. That makes it a 30. Then you have a 2 left. So it's the same as 324, just like we have it. Alright, so now let's convert 360 grade now to rad. Okay, so that's the next point of call. I'm going to wipe this off now. So that's the next point of call. Alright, so I'm converting, this is the A part, and of course the B part now says we are converting 360 degree, which is the given unit now, 360 grade rather, we are taking this to rad. Rad would mean the desired unit, right? So the given is 360 grade, and I could pick a pair of equivalent statement now that relates grade with rad. So I do know that 100 grade, but at the end of the grade will cancel out. Is equivalent to pi over 2 rad. Pi over 2 rad in radian. Right? So I lose the grade, I lose the 0. So I'm left with 36 times pi over 2, okay, divided by 10, and this is in rad. So clearly 2 into 2 is a 1, 2 in 36, okay, that boils down to the 18. So what I have left now is 18 pi over 10. So this is 18 pi over 10. And of course 2 could go in 18 and a 10. So 2 in 5. I mean 2 in 10 is a 5. 2 in 18 is a 9. So this is exactly 9/5 pi, okay, in radian. That is what this boils down to be. And of course you could also do it this way. Like I have 360. You have 360 times, now I have pi over 2 in rad. This is a pure ratio. You have a dividing line here, and I have a 10 down. So you could imagine, you could think of this 10 as 10 over 1. And of course, we have 2 pairs of ratios here. You can't divide 2 pairs of ratios, but you could multiply out. You could multiply them and flip the second pair of ratio. So this turns out to be 360 times, I have the first pair of ratio, pi over 2 in rad. This division sign changes to times, and I will flip the second pair of ratio down. That is 1 over 10. Right? So clearly, right, I could still use the 0 here. Right? And of course, 2 in 2 is 1, 2 in 36 is 18. Right? Okay, and if I do it this way, yeah, I'm seeing 18. I'm seeing 18 pi rad. 18 pi rad. I thought I deleted the 0 there. Okay, so I think, let me see. I guess I screwed something here. I screwed something up here. Let me also check this properly. This is what I'm getting. So let me properly check this also. So let's see. This is as good as saying, okay, there's a times here. This is 360 times. I could bring down the 2 now, okay? So I have pi rad. So I could bring down the 2, right? Just like we have here, okay? So this becomes 2 times 10. So I could lose the 0 here. Yeah, 2 into 1, 2 into 36 is 18. Alright, so this is exactly 18 pi in radian. So that is what 360 grid would correspond to. Alright, and you could check this. If you convert 18 pi rad to grid, okay, we could get 360 grid. Alright, so let's proceed now. Can I rub this part off? Alright, you need to build this for a while. I'll rub this part off. Alright, so now I want to convert. I'm interested, okay, in converting now. Okay, this is example 2, right? Okay, I want to convert, okay, 54 degree, okay, 16, or let me use 50 minutes, okay, and 24 seconds. Okay, I'm converting this to the A part now. Okay, I'm converting this all to degree. Okay, the B part, I'm converting this to radian, and of course the C part, I'm converting this, okay, to grades, okay. All right, I'm going to wrap it up here for the sake of time, okay. While I go fetch my calculator, so I'll continue in the subsequent video. Thank you if you're into the channel and you want to like, share, and subscribe for more content. Thank you.